Penn State On Demand is a service of Penn State Public Broadcasting, and now you can support WPSU when you shop online. Visit WPSU.org/shop to make purchases from national online retailers, and WPSU will receive a portion of the sale with no extra cost to you. So start your online shopping at WPSU.org/shop.
I do some consulting work on American
feeling in the room was
Don't ever say to her that her
What about the Chautauqua Institute?
Introductory discussion on the ethical implications of a community.
before China took back over.
currently doing in autism.
Our next guest has spent most of his life trying to make time travel, one of man's favorite science fiction fantasies, into scientific reality. As a young boy, Ron Mallett was devastated by the death of his father, but he found hope in an unlikely source, H.G. Wells' The Time Machine. After reading a comic version of the classic book, Mallett came up with an idea to see his father again. He would discover a way to travel through time. His quest led him to pursue a Ph.D. in physics from Penn State. He is currently a professor of physics at the University of Connecticut and has developed a time travel project based on Einstein's theory of relativity. Mallett chronicled his lifelong quest in his memoir, Time Traveler, a scientist's personal mission to make time travel a reality. Award-winning director Spike Lee was so captivated by Mallett's story that he's currently developing the book into a movie. Here's our conversation with Ron Mallett. Ron Mallett, welcome to the conversation.
Thank you very much. It's a pleasure to be here.
You are a respected theoretical physicist today, and the motivation for everything from learning math and learning science, going to college, becoming a physicist, all was motivated by a goal to see your father. Tell us a little bit of the background that set you on this lifelong course.
I'd be happy to. It was my father, as you said. I mean, he was actually the root of everything that has led me to where I am right now. I mean, he was a bigger-than-life person. He was a television repairman in the Bronx in New York. He had fought in the Second World War. He was a battlefield medic, and he used the GI Bill to study electronic technology, and he became a television repairman. And he was very, very good at his job, and he was very busy, but he had plenty of time with his family. I was the oldest of 4 children, and I felt as though almost like an heir apparent. He would tell me, he would give me scientific toys like gyroscopes and crystal radio sets, and he was even beginning, I think, to groom me to go into his field, because he was, as I got older, he was telling me about parts of the television set. And he loved to go to movies, he loved to take us to park, and it was just as I said, he was focused on his family as well as on his work. He looked like this robust, energetic man. What we didn't know was that he was seriously ill. He had a weak heart, and he died of a massive heart attack when he was only 33 years old.
And you were only 10.
And I was only 10. And my world came crashing down around me. I mean, it just literally collapsed, and I imploded. I went into myself, and I became really a depressed kid. The thing is that I loved to read. That was one of the other gifts that he left me. And about a year after he died, when I was 11 years old, I came across a book that really did change my life. It was H.G. Wells' Time Machine. And as soon as I saw that, I knew this was the thing. This was going to save me. This was going to be my goal, because if I could build this time machine, then I could go back into the past, I could save him, tell him what was going to happen, and see him again, and then change everything. And so I focused on that. The thing is that even at that age, though, I was astute enough to realize that people were already concerned about me. And if I told them that I wanted to build a time machine, I'm not sure what that would lead to. So I kept it as a secret. It was my secret project, but it did help me. And about a year after that, when I was about 12 years old, I came across the second book that changed me. It was called The Universe and Dr. Einstein by a man named Lincoln Burnett. And this particular book, on the cover of it, it was just one of these paperbacks that I found in Salvation Army. And it showed Einstein standing next to an hourglass. So I knew that somehow, just from the cover of the book, that it meant that Einstein was somehow related to time. So it was hard going through it. Even though it was a popular book, but it did talk about the fact that Einstein said that time was not something that was fixed. Time was a river that flowed and could be altered. The stream could be altered. And I thought, well, if you could alter time, then maybe a time machine is possible. So Einstein became my second major focus. I figured if I could understand Einstein, then this might help me to understand how to build a time machine.
This was a closely guarded secret of yours. What was it like to keep that a secret, except for a few very, very close confidants? Your wife, for example, your first wife knew that this was something you wanted to do, and some other close confidants. Did that eat at you, having to keep it?
Yeah, it was a strain. I mean, it was really a strain because it kept a distance between me and everyone else. I sort of felt like I was living a double life. And for a while, I actually was. I mean, when I was in the Air Force, I was single. And I went to the Air Force. I should mention that after my father died, the family plunged into poverty. And that was a significant factor because college was not something that was automatically in my future. And so I knew that if I wanted to go, I was going to have to almost follow my father's footsteps. So I went into the Air Force during the Vietnam War period, and I used the GI Bill after I got out. But the whole time I was in the Air Force, I had zero social life because I was focused. In fact, I purposely went on the so-called graveyard shift. I was a computer technician so that I could isolate myself and spend my time studying. And that was my life. My life was this particular focus and this particular goal. And I felt alone. I mean, I felt, I didn't have, anything except that. But so that was, it was a bit of a strain. And I couldn't trust. There was only a few people that I felt that I could trust with it because I didn't want to be thought of as being crazy.
Which is probably why you became a theoretical physicist rather than an experimental physicist.
That's right, that's right. And also because of the fact that Einstein was a theoretical physicist, and I felt that by using mathematics, I mean, theoretical physics is essentially it's a physicist who uses the tools of mathematics to try to understand and probe the secrets of the universe. And so I felt that if I was going to find a way of doing that, I would find it mathematically. And this is something that I could keep as a secret because as an experimental physicist, you're sort of, out there, and as a theoretical physicist, I could use my secret area was black holes. And as I tell people,
this was your cover,
that's my cover, right, because black holes were considered a radical idea, but it was considered sort of legitimate crazy.
And explain what a black hole is. A black hole is a star that has disappeared.
Yes, that's right. When stars start to burn out, what happens is that there's no longer that internal energy in there to keep them from further collapsing. So they start to collapse, and as they collapse, the gravitational field around the star starts to get stronger and stronger and stronger. So strong that all the life that tries to get from the star gets pulled back, and all you see is a black hole, because no light can get out. So it actually acts like a hole in space. What it does to time, however, is also interesting, and that was what interested me, because according to Einstein, as gravity becomes stronger, time will actually slow down. In other words, a clock will actually start ticking more slowly if gravity becomes greater. I should mention Einstein developed two theories. One theory says, part of his theory, which is called the special theory of relativity, says that time is affected by motion, okay? So that the faster you move, the more time slows down. And that's the effect that you're talking about with the Russian cosmonaut. And that has been seen directly. Einstein's other theory, which is his general theory of relativity, says time slows down due to gravity. So there's two theories. One says that time slows down the faster you move. The other portion of his theory says that time slows down due to gravity. So, and we actually see that effect too. I should mention, for example, one of the ways in which we see that gravity affects time is your GPS. In the GPS system, what happens is that right now, above the Earth, about 12,000 miles above the Earth, there are 24 satellites that are orbiting constantly. Those satellites send a signal to your unit in your car. That satellite has a clock on it. Your unit has a clock in it. So what's happening is that the satellite sends a signal at a certain time, and it reaches your unit at a certain time. What you can do is you can use the fact that it's sending the signal at a certain time and it reaches at a certain time, you can calculate the distance of where you are on the Earth because you know the speed of the signal. The problem was that when engineers were setting this up originally, they were running into errors. It wasn't working properly. And that's because they didn't take Einstein into account, because the clock in your unit on your car is running slower than the clocks on board those satellites. And so without that, without taking that into account, they were actually having problems. When they used Einstein's theory and calibrated it, what they realized was that they could adjust it. And now the system is working properly. So we do know that time is affected by gravity as well as time is being affected by speed.
You've been influenced throughout your career and throughout your pursuit by Einstein, who, interestingly enough, was very progressive in terms of race. He really called race issues in the United States a tragedy for American Negroes, which is the way he put it back then. How important was Einstein to you, not just as a scientist, but as a human being?
Right. Well, you said it exactly right, Patty. I mean, the thing is that he was important to me as a human being as well as a scientist, because the thing is that he was a person who fought for the underdog. I mean, he was someone who said it was important to understand human rights of people. And the thing is that, so for me, he was a beacon. I mean, and the thing is that, and it was something that I felt was important too, to be aware of the fact that everyone needed to be treated with respect, regardless of their life, regardless of their station. And so as a person, I mean, I read many biographies of Einstein so that I could gain more of an insight into him as a human being, as well as the work that he did. But to me, that was what makes him great as a scientist. As you know, he was called the person of the last century by Time magazine, was the fact that he was a great humanitarian as well as a great scientist.
It's interesting to think that had your father survived, you might have become a partner in his TV repair business. Yes. On the other hand, as you pursued your goals, your stepfather thought, why would you become a physicist? He had plans for you when your mother remarried for you to become the manager of a local gas station. He did not understand what this crazy stepson of his was into. That must have been a difficult time as well.
It was a very difficult time. In fact, that was the contrast between my stepfather and my father. My stepfather was someone for whom education was not important at all. He did not read. He had no interest that I could see. And the thing is, but he was a good provider. I have to say, that was the one thing about him, that he was a good provider. But outside of that, I mean, that was a constant tension between him and myself. And it was a complete, it made life extremely difficult for me.
You came out of the closet about your mission and about time travel to a group, an international group of physicists in 2002. The reaction, I think, surprised you.
Yes, it did, because I was expecting a hostile reaction, is really what I was expecting. However, at this particular point, I knew how physicists behave and think. I mean, the thing is that, and this is something that people don't are aware, they think that sometimes when someone says they have a theory, that's the same thing as saying you have an idea. In physics, when you say you have a theory, that means you have a completely developed system, a mathematical system that actually makes predictions. This is not just simply saying an idea. And so when I went to the community and I did develop this, I actually had a completely developed system of equations that were based on Einstein's theory. So I knew that I had a rigorous foundation on which I was, so that was where I was feeling comfortable. I wasn't sure how they were going to respond to what the goal was, but I knew that I had everything in place as far as the correct mathematics was concerned.
Where are we in this whole time travel pursuit? What is possible?
Okay, well, time travel in the future is already possible. As you pointed out, we've seen that with the cosmonauts, and there's been an experiment, in fact, that the public generally isn't aware of. This was done in 1971 at the Naval Observatory. What they found was that atomic clock, which is the most precise timekeeping mechanism that we have, what they did was to put it on an ordinary passenger jet. And as I said, according to Einstein, speed affects time. And what they found was that when they flew the clock around the world and brought it back and compared it to a clock that had been at rest, that the clock on the passenger jet had actually slowed down. Time had actually slowed down. This means that the scientists that were on board, their heart rate, their metabolism had slowed down. So they were actually a little bit younger than their counterparts. So This time travel into the future is something we've already seen the baby steps on. Once we have rockets that can go sufficiently fast, we'll see this not just in terms of fractions of a second, but we'll see this in terms of years. So time travel to the future is something that we've demonstrated, and it's only a matter of time, so to speak. It turns out that, as I said, gravity can affect time, but what most people don't realize is, everyone I think realizes that matter creates gravity. According to Einstein's theory, though, light can also create gravity, even though it's not made up of matter. It's just energy, but it can create gravity. What I realized was that if light can create gravity, and gravity can affect time, then light can affect time. So my core idea was that by using light, you could actually alter time. So my notion was to have a time machine that was based on light, on using laser light. The thing is that, and that I developed the mathematical theory that's associated with that. But that's the problem with being a theoretical physicist. What I've done is I've constructed the equations that show this is possible, but in order to do that, you need hardware, you need experiments, and that's where experimental physicists and engineers come in.
And you're working with someone at the University of Connecticut.
That's right. I'm working with an experimental physicist. His name is Chandra Chaudhry, and he's a laser specialist. And so he became interested in my work, and so he's working with me. It turns out, however, that people at Penn State became interested. I should mention that a year ago, the Penn Stater, our major alumni magazine at Penn State, they did a cover article on me in their summer issue. And that had a wonderful response because Penn State has a center, it's called the Penn State Electro-Optics Center. And
in Pittsburgh.
in Pittsburgh, that's right. And one of the scientists there saw that issue, and he reached out to me and said that he would be interested in collaborating with me. So his name is Ben Campbell, and he has a colleague named Vlad Simak. And Vlad is actually here at State College, so they have been collaborating with me too.
The reality is that in the last couple of years since you came out of the closet, you have been inundated with newspaper requests. A film documentary was made about your life and your mission. This American Life did a piece on you, which I should mention really got your story to the film director Spike Lee, who's interested in doing a story based on your memoir, Time Traveler, a scientist's personal mission to make time travel a reality. Tell us a bit about that film.
Yes, well, I mean, the whole process was really fascinating. Spike Lee teaches film at New York University, and two of his graduate students heard of This American Life piece, and they got the book, and they went to Spike and told him about it, and Spike was like, you're kidding, you know, there's this African-American scientist who's doing time travel, and he became and he taught, in fact, it was interesting, he was giving a talk this was a couple of years ago now, at University of Connecticut. So he asked to see me, and at the time, this was near the 1st of April, and I thought it was just simply an April Fool joke when the physics department told me that he wanted to talk to me. But he contacted me directly and said he'd like to talk with me. So we did. We got together, and I gave him an autographed copy of my book, and he said, this is really a great book, so I'd love to make a feature film of it.
I think, for me, the first question I wanted to know was, who do you hope will play you? But I know that the more important question to you is, who will play your father? Who would you like to play your father?
That's right. I have to be careful about saying publicly who I would like to have, because Spike has people in mind, and I do too. And he has told me, you know, to be careful about saying. And so the thing is that there are many, many talented African-American actors out there. And so to me, I have some in mind that I would like to, but as you said, for me, what's even more important in many ways is who's going to play my father, because Spike is almost going to be like bringing him back for me.
That will be your time travel, the movie, when the movie comes out.
Absolutely, and that's one of the things that I'm really, really excited about. And I should mention that just recently the script has been finalized. It's been fixed. I'm in the contract, and I had a chance to review the script, and it's beautiful. I mean, I really think it's going to make it a fantastic movie. And the thing is that now it's going on into the next stage in which Spike's agents will be talking to the Hollywood studios and to actors to see, who. So stay tuned to that portion.
When you earned your PhD, you became the 79th African American physicist, and since then, as an associate professor and eventually a full professor at the University of Connecticut, you've spent a lot of time helping to recruit the next generation of African American scientists. Where are we today? Has that changed much?
No. As a matter of fact, the proportion hasn't really altered that much. As you said, I had the 79th PhD at that time, and put it in perspective, there were 20,000 PhD physicists
in the U.S.
At that time. So this was 79 out of 20,000. Now I would say that there's probably around 30,000, and there's probably around 300 out of that. So it really hasn't altered dramatically. That's a problem. That's really a problem. What's nice, though, is that women have made great inroads. That has increased. But as far as the African American community itself, it really hasn't increased that much as far as, and that's a problem. As I said, I think part of it has to do with the esoteric nature of the subject itself. I mean, and I think this is so, not just for African Americans, but for people, men and women in general. They can see engineering, they can see being a physician, a lawyer, television producer, television,
we can't see time.
We can't see, you can't, right, it's hard to see. Physics is it's out there. And so it's hard for people to see, how am I going to make a living, doing this, as a matter of fact, which was one of the arguments that was used to try to get me to alter my course away from
In
this.
fact, you left private industry and went into academia, taking a 50% cut in pay, but it was interesting for me to read that it was work that you did in private industry that has helped you tremendously in what you're doing now.
Yeah, it's interesting. Sometimes it almost seems like there's a divine plan out there, a larger plan, because at the time when I after I got my PhD and I went into industry, I was kind of disappointed because I rather had gone right directly into the university. But if I had not taken that path, I wouldn't have learned about lasers. And it was actually learning about lasers in industry that eventually was the key to unlocking the secret of time travel for myself.
Now, if you'd end by telling us how your goal has morphed into something entirely different. You no longer are set on going back in time and seeing your father. What is it? What is your goal today? What questions are you asking about time travel?
Well, the thing is that, number one, I would like to see the process happen, but I know that there's certain limitations that are associated with it. To me, it's important. Time travel is important because of the fact that it gives us an unprecedented control over our destiny. For example, one of the things that people ask is, what can a time machine be used for in general? It can be used as an early warning device. Imagine, for example, that we had a device, a way that could tell us about future catastrophes, that would warn us about tsunamis and earthquakes.
But if we changed history, we could change whether we ourselves existed.
That is a subtle
that
question.
grandfather paradox.
Grandfather paradox, and that's a very, very important point, because when you go back, if you go into the future, there's no problem. But if you go back into the past, you may interfere with something. For example, the classic grandfather paradox is, in fact, if you go back and prevent your grandparents from meeting each other, then they don't have your parents, and if they don't have your parents, they don't have you. So number one, it seems like it's a paradox. How can you do that? And if you do that, couldn't you erase your existence? I think that it's much more subtle than just simply that. I mean, number one, there is another aspect of physics, quantum theory, which says that may not happen. That is to say that when we go back and try to alter the past, we may actually end up in a parallel universe rather than our own universe. And in that parallel universe, we can alter things, because that's not the universe we came from. But in the original universe, it goes on the way in which we do. So we might be able to alter the destiny of another universe.
And of course, this sounds like science fiction, but major physicists are working on parallel universes.
That's right. This is actually based on real physics. This whole notion of parallel universes, and as I said, it's anchored in quantum mechanics, which is actually the other pillar of physics besides relativity. So this is actually considered a very serious domain.
Well, let me end with this, because you're not working on a flux flux incapacitor, which is what Doc Brown in Back to the Future was using. Tell us a little bit about your time machine.
Okay. Well, as I mentioned, it's based on using light. And the fact that it's anchored in Einstein's theory, because Einstein showed that gravity can affect time. And as I said, since light can create gravity, then my theory is based on actually using a circulating light beam, which you can create. You can take lasers and you can get laser light to move in a circulating path. And what this will actually do is this will actually cause time to get twisted into a loop. Normally we think of time as something that goes from the past, present to the future.
Linear.
That's right, linear. If you can twist time into a loop, then you could go from the past to the present to the future, but you could go from the future back into the past. And what I've been able to show is that by using circulating light, you can actually twist space and you can twist time into a loop. And this would allow you to go back into the past.
And rather than a human, you're working with subatomic particles.
That's right. And the thing is that information is what we would eventually be able to send back into the past. And as I said, information in many ways is even more important than trying to send human beings back, because we could signal ourselves about future disasters and maybe avert those disasters.
Ron Mallett, thank you so much for talking with us.
Thank you. It's my pleasure.
I hope you enjoyed our conversation with Ron Mallett. Comcast subscribers can watch this program anytime on Penn State On Demand. Find out how through our website, conversations.psu.edu, where you'll also find further explanation of Mallett's theories on time travel. I'm Patty Satalia. Join us for our next conversation from Penn State.
If you've enjoyed Conversations from Penn State and would like to purchase a DVD of this show or any of our other episodes, order online at mediasales.psu.edu or call 1-800-770-2111.
Production funding provided in part by the Corporation for Public Broadcasting and by viewers like you. Thank you.
This has been a production of WPSU.